us to organize this online event. Next speaker for the day is Mahesh Jagwani. He's a graduate of D.Y. Patil Dental College, Mumbai, and he's been practicing in Mumbai since 2010. He's an in-house dentist and academic advisor at Illusion Training and Education. He contributes to knowledge sharing through his YouTube channel called Chairside Education. He's been trained in France and Belgium for intraoral scanning by Professor Duret, who is widely acknowledged as the father of CAD/CAM dentistry. He's also taken a diploma from 3Shape Academy in Copenhagen, Denmark. And today he's going to talk to us about integrating digital dentistry and overview. Over to Dr. Mahesh Jagwani. Mahesh, you need to unmute.
Am I audible now?
Yes.
Great. Thank you so much for that letting in and the intro. It's always a pleasure being a part of E-Famdent, and today I've been given this Herculean task of talking about integration of digital dentistry in about 45 minutes or so, but I assure you I'll do my level best and try to do complete justice to the time slot that we have allocated here today. So I hope my screen is visible now. Is my screen visible?
No, not yet. Now it's coming. Now it's
okay,
coming.
Perfect. So as you all know, dear delegates, the topic for today is integrating digital dentistry. And since I said that it's already a very vast topic covering a gamut of different situations that we can incorporate, it's going to be more of an overview. But after this, we'll be present at our booth at Illusion Dental as well, so we can virtually connect also. Now, talking about digital dentistry, you know, there's a lot of aspects to digital dentistry when it comes to the clinical aspect. So you talk about digital photography, intraoral cameras, RVGs, milling machines, CBCT units, and so on and so forth. But you know, the crux of the matter today, the moment we talk about digital dentistry, the term which automatically comes to our mind is CAD/CAM. That's a very synonymous term with digital dentistry, and hence I'll be talking more on the CAD/CAM and intraoral scanning front today, which happens to be the area of my expertise as well. We have all heard this term before. As I said, whenever we talk about digital dentistry, the first term which comes to our mind is CAD/CAM. Stands obviously for computer-aided design and computer-aided manufacture. We all know what CAD/CAM is, right? Let's take a deeper look into what exactly CAD/CAM is. When we talk about CAD/CAM dentistry, as we know it, in essence, we send our impressions to the lab. The lab technician pours a model out of it. The model is then scanned on a desktop scanner, which is a tabletop scanner, as you see on the left side of the screen. It's then converted into a digital file where the technician designs your restorations, and thereafter the file is sent to the milling unit for the milling and the manufacturing process. So we have always regarded CAD/CAM as one of the most accurate techniques that dentistry has to present to us today. Now, we all know this little material that we've been using in dentistry for centuries. I mean, for as long as dentistry started, we've always been dealing with gypsum products. It's actually been our best friend. What exactly happens with the gypsum model? Now, as I said earlier, our impressions are sent to the lab. They are converted into a positive. An impression which is considered to be a negative replica of the teeth is converted into a positive, which is the die stone model. It is then scanned onto a desktop scanner, like you can see in the video on the lower left, and the technician designs the restorations in the lab and delivers them to us. But is CAD/CAM dentistry per se, especially in the physical workflow, 100% accurate? Let's take a minute to realize that CAD/CAM dentistry is only as accurate as our die stone model is going to be. So in case there is an error at the impression stage, that error is obviously magnified once the models are poured, once the models are ditched, once the models are die cut. So all the steps actually require manual intervention. And hence, there is never a 100% accuracy that we can get out of conventional CAD/CAM dentistry. So in order to counter this problem, we've been exposed to so much in digital dentistry these days, and there's a bit of a buzz all over social media. Everywhere you go, everybody is talking about intraoral scanners and digital impressions these days. It's a relatively newer phenomenon, and it's slowly taking over analog or physical dentistry in terms of physical impressions. So, as we know, there is a wide range of scanners which are available outside. A lot of them have some advantages, a lot of them have some cons as well. But for the purpose of evaluation and for the purpose of this presentation, I'll be using the three-shape trios for the demonstration purposes. And as a prototype, it's a scanner system which originates from Denmark in Copenhagen. So we'll get a deeper insight into how the intraoral scanners work. So the workflow is simple. Just like in a physical or an analog impression workflow, we start with taking the lower arch impression, we then take the upper arch impression, and we register the patient's occlusion or the bite registration, as we like to call it. The process remains the same for intraoral scanning as well. You can start with the lower impression or the lower scan, switch over to the upper, and record the occlusion on both sides. So it's like a digital impression taking mechanism. Now, when we talk about advantages and we talk about the ease of workflow, a lot of times, all of us have witnessed this scenario where the lab technician calls us the next day after we send an impression to the lab. And what does the technician tell you? Doc, there are so many undercuts in the prep. We haven't prepped the teeth enough to remove all the undercuts. I am not able to get a path of insertion or a path of draw, as they like to say. I'm sure all of us have encountered this situation before. And it's really, really painstaking to having to call your patient again just for this little correction. And trust me, it's not the dentist's fault, because a lot of times these kind of undercuts are extremely difficult to visualize inside the mouth. Sometimes you cannot even see these undercuts because you're so fatigued dealing with a big case such as this one. So with the advent in digital technology, the software now tells us, you see these colored areas in green, yellow, and red? These are different ranges of undercuts. So while the patient is sitting in the chair, I have 100% idea of where the undercuts are. I can take my burr, adjust those areas, and just rescan that much portion of the teeth and send this corrected file to the lab immediately while my patient is still in the chair. So this gives us complete control and allows us to optimize our digital dentistry resources at the clinical and lab level. It's pretty interesting. Another very common pain area for a dentist who's doing restorative dentistry is, again, communication with the lab person or the lab technician in terms of having inadequate clearance. You see that red spot here? The software also tells us in which areas there is less clearance. So if I were to do a monolithic zirconia in this case, I can easily blow up the scan on the screen, say 10, 15, 20 times, and visualize that area where there is less clearance. Take my burr, take a flame shaped burr, go back to the mouth, trim that, get the scanner back inside the mouth, and stitch. We call this process stitching, where new piece of information is added to the original scan. Quite interesting, extremely, extremely helpful in daily dentistry. So here's a simple straightforward case of a 3-unit bridge, which we prepped and we scanned with the intraoral scanner. This is the pre-op situation. The patient reported with an already root canal treated tooth, and because of a lack of ferrule on the mesial aspect of the 7, we decided to do a laser gingivectomy. We prepped the teeth, we had some retraction cords inside, and we started with the scan sequence. So I'm going to run you through a quick video demonstration of how the scans for this case was complete. So the scanner goes inside the mouth, and you can see how quickly we can capture data from all the 3 aspects. I can also use the trim option to eliminate all the unwanted soft tissue from the scan, because we don't need that for restorative purposes. Then we come to the working scan. So you see the retraction cords are in place. The scanner is moved around, and you can notice the smooth movements that we do with the scanner to cover all aspects of the teeth to form a 3D model. We then ask the patient to have their mouth closed. It's important that the patient's head is upright, because we want to record maximum intercostal position in this case, and the arches snap into place automatically. So that's how easy our clinical workflow is. Once this step is complete, we send this file to the lab, and this is what the technician receives. You can see the nice marginal definition, and a lot of times we face a lot of issues with our margins. Sometimes our restorative margins with the crowns, with the bridges that we get, they are short of where the real margin is. And that happens because of lack of clarity on the marginal area. And that is where scanners can really help us capture accurate detailing along the margins. So this is what the technician is doing in the laboratory, is designing our zirconia bridge. And you see this model is also going to be printed. So there are two files which are sent out. One of them is a 3D file of the model, which is sent to the model printer. And there's also another file of the bridge, which is sent to the milling unit. The prosthesis is milled and sent along with the models to us. And this is how we deliver and get absolute control over the most critical areas of the preparation, that is your margins. Very, very minimal, you can say, corrections required as far as occlusion is concerned. Absolutely negligible amount of, in fact, zero repetitions with digital cases, and perfect occlusion every time. Accuracy, predictability, precision. Now, another tip when it comes to CAD/CAM dentistry, a lot of times we hear our technicians call us up and say that, Doc, I see some sharp margins on your preparation. Why don't you round them off? Why don't you round them off? Because otherwise I will not be able to give you the right kind of prosthesis. So why do you think the technician tells us this? Let's take a look. So whenever we talk about milling in the lab, you see all the tools that are used for milling have a rounded tip, like the one here. They are not sharp or pointed like our clinical burrs. So what happens when we have a nicely rounded line angle on our prep? The burr, when it comes down in the milling machine, it can actually go to the depth of that area, that rounded area, and carve the entire thing out in toto without any errors or without any mishaps. Let's take a minute to understand on the other side, where we have a sharp margin or a sharp line angle here. What will happen? Because of the rounded tip of the burr, it's impossible for the tip to get into this area, and this area of the tooth remains unmilled, and we have an ill-fitting restoration. So next time when our technician tells us to round off the margins, this is something that he's actually considering. Obviously, there are also instances where, because of a sharp line angle, there's a lot of stress concentration. It can cause prosthetic failure. But this is another important reason which we need to understand when we do our prep. That's why it's always advisable to round off the line angles before we send the files to the lab. This is another case where there was a previously a PFM bridge, a long span PFM bridge. It was removed. The undercuts were removed. If you can see, there are a whole lot of undercuts, because of which there was a lack of complete seal and some leakage. So everything was cleaned, preps were modified, scans were done, and prosthesis delivered. So this is a smart zirconia, which is a kind of monolithic and layered prosthesis. We always prefer monolithic prosthesis in the posterior areas, and you can see the nice marginal integrity and absolutely perfect, flawless occlusal surface. Really interesting how good control we can get. Now, a lot of times when we deal with zirconia bridges, as far as CAD/CAM is concerned, I hear a lot of people talking about bridges fracturing or breaking, and the most common area of breakage of a zirconia bridge will be the connector. So why it happens is because of this phenomenon. What happens is, for zirconia, we need a minimum volume of the connector to be present. So we need a minimum height and a minimum width. If the height and the width are not sufficient, there are good chances that the bridges might fracture from the connector. So let's see what I'm talking about. There's something known as the rule of 27, which means the height of the connector squared multiplied by the width of the connector. This value that you get should be equal to or more than 27. So that means if I have a connector of 2.3 millimeters in height, and if I have 1.9 millimeter connector, the height square multiplied by the width is 10.14. Now you see this value is significantly less than this 27 that we need to aim for. And that's why we're in the danger zone. There is good likelihood that this prosthesis might fail in the near future. It might fracture from the connectors. So for all those of you who are having issues with zirconia bridges fracturing at the connector, It's always important to take into account the rule of 27. On the other hand, if we have another case where we have a good sufficiently long connector, say 4 millimeters, and a sufficiently wide connector, this value becomes 48. So this is where we want to tell you that always aim to visualize the connector, try to visualize the position of the connector, the dimensions of the connector, and then take a decision whether you want to go in for a zirconia bridge or not. So this is another case which walked into our training center, and this is an employee of Illusion. He came to us with, you can see there's a discolored and a completely out of shape central incisor that this person has. And the moment I saw this case, the one thing that came to my mind was this is big trouble. And there are certain challenges that we face in dentistry day in day out, and this is one of them. Now, to match a single restoration along with natural adjacent teeth is one of the most difficult challenges for the clinician and at the technical level. So what did we do? We took a pre-op scan of this case, and you can see that this is the pre-op scan which was sent to the laboratory. Now, the technician has, thanks to the CAD/CAM workflow, he has a mirror tool. I can mirror this natural central incisor on the patient's jaw and get it to reflect on the other side in place of the existing crown. Let's see how it happens. So now the technician has mirrored the central incisor. Now we have a completely symmetrical looking central incisor, which is matching the patient's existing central. Again, some finishing touches is what the technician does. It's an exact mirror image of the tooth. So he adjusts occlusion. All this is happening at the lab level. Once this is done, the technician sends me a 3D printed model of the mirror. So now if you see, compared with the initial situation, this tooth, the 2-1 has been mirrored to appear just like the 1-1. I'll come to this model in a bit. Now comes the time of scanning the patient. The crown was removed. It was cut with a carbide burr. Since it was a PFM crown, it was removed. Scan was taken with the scanner. So we had 2 cords packed into this case. You can see a nice open sulcus, and because of that, you get a nice marginal definition around the prep. I also have an option of locking the retracted portion of the gingiva. So now with the help of the scanner software, I can lock that area so that even if the gingiva collapses, it will have some memory. So it'll obviously have to collapse. Even if it collapses, the scanner is not going to update that part. It's going to be retracted. Now the software also gives me an option of recording the patient's shade digitally. Yes. So we always recommend taking a manual shade first, and the technician at the lab end can also use this file, the 3D file which we sent to the lab, for matching characterization and shade. It's pretty interesting. Now you remember the model which the technician had sent to me. What I need to do now is create a putty suck down stent on this, use it to temporize the patient so that the patient gets a bit of a test drive as to how the incisor is going to look. Obviously, the patient approved this, and this is the final restoration that we have in place. So you can see the perfect shade match, you can see the value match, and obviously the shape. And this can be done with very nicely, beautifully crafted artistic crowns where we have zirconia coatings inside, and it is layered with a layer of Emax porcelain to give it the required strength, the required aesthetics and characterizations as well. And this is how a seemingly difficult case can be made quite easily with perfect communication with the lab through the digital dentistry workflow. Now we saw a case of a 3-unit bridge. We saw a case of a single central incisor. The process remains the same for full arches as well. So you scan the lower, you scan the upper, you scan the occlusion and send everything to the lab. The process remains exactly the same. So no limitations at all. You can use digital dentistry in a lot of complicated and big cases as well. So what does the scanner mean to me? To me personally, the scanner is one of the most powerful tools that CAD/CAM dentistry has to offer to us. For me, the scanner is synonymous with power. But we all remember what our friendly neighborhood Spider-Man once said, don't we? He said that with great power comes great responsibility. Now, what is this responsibility that I'm talking about? You know, a lot of times when I go out, I meet dentists, I interact with a lot of dentists for scanners. They always have to ask me this one question where they always point out and say, "Doc, even if we buy the scanner, do we still have to control moisture? Do we still have to remove saliva? Do we still have to mop off all the blood?" The answer is yes. With great power comes great responsibility, because without isolation, it's extremely difficult to record the finer details at the margin. So you can see the clear cut difference. On the left, we have a scan taken without isolation. On the right, we have a scan taken with a standard level of isolation, which we anyways do for routine dentistry. You can see the nice definition along the margins. And that is what we want to see, right? It's always important to maintain some levels of isolation. Another way of maintaining good isolation is gingival retraction. Let's take a look at this case, for example. Again, a single unit crown. Now, a lot of people, and including myself, I strongly suggest the use of two cords wherever possible. A lot of times it's not possible to place two cords, but wherever possible, especially when the gingival biotype is thicker, you can always go for two cords. What happens is the first cord gives us vertical retraction, which allows us to work on that margin. And then we have the second cord, which is a larger cord. It is taken out before we take the scan. Let's take a look into further detail. The moment we remove the top cord, you can see this nice wide open sulcus, which allows me to capture a good impression or a scan in this case and transfer this marginal detail to the lab without any hang-ups. So from the technician, there is no more guesswork. You can actually see where that margin is located. So this is the same case in action. We've taken a scan along. So the first step is to always record the scan with the top cord. And I have a trim option. You can see the trim option on the left side. I can take the trim tool. I can trim off the retraction cord area from the scan, go back to the patient's mouth, get the top cord out. Now all I have to do is just take my scanner back in and record the margin and stitch it to the original scan. Remember, we spoke about stitching, and that is the kind of marginal detailing that you want to see on your pets. And this way we are 100% assured that there's going to be no kind of marginal issues whatsoever. And all this is possible easily to do with a intraoral scanner, where you need not take the entire impression again. A lot of times with physical impressions, we fail to record the margins because of isolation, whatever reasons. The scanner allows us to take it step by step, scan in bits and pieces, allowing more comfort to yourself and to the patient as well. So no more repeating impressions. So this same case was treated with a component of chairside dentistry, where I could use the same scan file. And as you can see, I'm designing my own crown in the clinic. And as I do this design, the technician is preparing the 3D printer. Now there are chairside 3D printers available, which allow us to print immediate chairside provisional, so that my patient can walk out of the clinic with some temporaries in place. You can also incorporate the same design if you have an in-house milling solution. In this case, we use the 3D printer to provisionalize. And in the same sitting, you can actually deliver an immediate provisional restoration to this patient. Another beautiful part about this digital file, it's completely open-ended, which means that I can use it for printing. I can also send the same file to the lab, which the technician processes and sends us the definitive restoration whenever you want to get it delivered, along with the model, and it is delivered directly to the patient. So that's why I always, consider digital dentistry as extremely, extremely powerful and strong, as long as we respect certain realms of basic dentistry. Coming to implantology, this is another, lot of people who place a lot of implants are always, oblivious of the fact that they have to take these impressions, multiple implants, splint them together, pick those up with open trays. And more often than not, we end up repeating those impressions a lot of times. which makes it a little difficult at clinical level. So we can now replace physical implant impressions with digital impressions. And just like we use impression posts, there is a component that we call a scan body. Now, the scan body is just like an impression post, but it is used in digital dentistry. So we use it along with a scanner. I have a live case to show you just in the next few coming slides. So we will focus on that. This is the case which I'm going to show you all. These are 4 biodenta implants which were placed, and the implants were uncovered after 3 months of placement. The second stage surgery was done, gingival form was placed. After about 10 days, the patient is called back and we are ready to take the scan. Now, when we talk about the implant workflow with an intraoral scanner, the first step is to record the emergence profile around the implant. Let's take a look at how that can be done. So first we take a gross scan along with the healing apartments. We take the trim tool, we trim out the healing apartments, which are then removed from the patient's mouth. And I am now recording only the emergence profile. So this will give the gingival profile to the technician and allow him to customize your restoration or abutment. These are the scan bodies which go inside. And now in the next step, all I have to do is just stitch or replace these scan bodies in the original scan. Now these scan bodies will serve the exact same purpose that the impression post does. It helps us transfer the three-dimensional position of the implant to the lab. And we took the upper impression or the upper scan, we took a bite scan, and we send this file to the lab. This is what happens in the lab workflow. Now you can see the technician is dealing with this file and he's trying to align the virtual scan body that he has along with the scan body on your scan. So on the left side of the screen, you can see the entire library that the technician has. He can select the implant system, what kind of platform, so on and so forth, and go ahead and design the processes. And the emergence profile scan helps the technician to design the emergence profile. So you can see how the emergence profile was designed in this case. This is what we receive from the lab. We receive 3D printed models along with the screw retained chrome cobalt restorations, which are taught into place and delivered. Again, with the scanner, it's very, very predictable. If you want passively fitting, perfect occlusion, perfect specifications, perfect customization for implants. It saves a lot of pain for a lot of implantologists. You know, another beautiful part about CAD/CAM dentistry, especially when it comes to implants is concerned, I love the way you can actually go ahead and customize your abutments. Abutments, screw retained restorations. The idea is customization. Let's take a look at this. This is a customized crown. This is changing lives. CAD/CAM dentistry can actually change lives. This is a bunch of rugby players who lost their teeth. They were craving a pint of beer. And this is what CAD/CAM dentistry can do. Amazing, isn't it? Life changing. We obviously don't want to flaunt this video in front of our patients because you don't want to start them opening beer bottles in front of you. But the point is that customization is the key. Like this smart abutment, for example. So smart abutment is where you can customize the abutment as far as shape. Like in this case, you can see the technician has given us a molar shaped abutment to replace a molar crown, which is more dynamically suited to carry occlusal loads. You can also customize the gingival collar. It's basically like buying a tailor-made suit for your implant rather than a ready-made or a stock abutment in this case. That is the power of customization. Coming to orthodontics. Now, orthodontics again is a very vast topic to cover as far as scanners is concerned. Digital dentistry and intraoral scanners can be used very, very effectively for doing aligner cases as well. So what happens usually is you take these scans, you register the upper scan, the lower scan, the occlusal scan, send these scans to the lab. They send you a virtual setup. A virtual setup is basically a kind of a simulation. The orthodontist in-house will send you a simulation of the entire case. And once you approve it, you can directly go for making these aligners on the digital file. So no more taking physical impressions for orthodontic cases. All you need to do is just get some scans, send some photographs to the lab, and you receive this kind of a virtual setup, which I've been talking about. So you can see the animations, kind of an animation where you can, as an orthodontist, assess the tooth movement yourself, or if you want to make some changes to this, you can always suggest these changes to the orthodontist, and you can show this to the patient as well. And once you're okay with the virtual setup, we correct the incorrect with aligners. So this is again a very booming field today, with a lot of people conscious about the way they look, the way they smile. Clear aligners is the next big thing, or already the new big thing in orthodontics. Now, talking about communication, we saw a lot of direct functions of the intraoral scanner. Let's talk about communication. Now, in the physical workflow, we are always so used to writing down big prescriptions to the lab technician. In this case, we can send a digital prescription. You can just select the teeth on the software, enter the specification that you need. Like in this case, we are using biodenta implants. We want some screw retained joint crowns on them with zirconia. And these are going to be all unified in the form of a single unit. So I can select the missing teeth as context, and I can join everything together and convey to the technician that I need a bridge. Because this communication is so foolproof and so black and white, so transparent, there's absolutely no chances that the technician can goof up. Imagine having placed multiple implants in the same patient, mentioning different implant systems, different implant subsystems, different implant platforms. All that can be done digitally, in this case, while using an intraoral scanner. Quite amazing. Again, we spoke about shade detection. Shade detection is another very helpful tool to use as far as digital dentistry with an intraoral scanner is concerned. So you can always add manual shade for your preference, especially when it is an anterior tooth, because what the technician sees is the technician sees different shades in different areas, because obviously the natural tooth is polychromatic, but you still have to give the technician a reference shade, or the body shade, so to speak, and the rest of the characterizations can be followed looking at the scan and taking different shades. Now, another major aspect is record keeping. A lot of us who have old clinics, have a lot of patients, especially the orthodontist, will be familiar to what image I have on screen now. We have these stacks and stacks of models stored in our closets, just so that the patient comes back. We want to maintain records. No more storing physical records, especially during these kind of phases where these stone models can be a high source of contamination. You don't want to store any kind of contaminated resources in your clinic. So you can always have digital records instead. You can store these digital models now instead of storing physical models, be it orthodontics, be it some major implant cases, be it some full mouth cases, be it regular record keeping. Everything can be done digitally now. All this is stored in the hard disk of your computer, can be uploaded to the cloud, all sorts of options. So this is where the intraoral scanner also helps us. This is another extremely beautiful way of keeping track of treatment, and also a lot of records to it. So if you see at the bottom of the timeline, I have scanned this patient on multiple occasions. So starting from the 9th of August 2016, I hope you all can see the bottom of the screen, all the way up to 30th August of 2019. I have around 7 to 8 scans, and the software can actually give me a simulation of this ortho patient to see how much of tooth movement has happened. So you can see and you can show to the patient that you've managed to move your teeth from a not so ideal position on the 9th of August 2016 to a more ideal situation on the 30th of August. And not just that, not just visual, I can also quantify the amount of movement. I can quantify the amount of movement when I choose this cross section. I can just draw the cross section here, and I can measure as to how much the tooth has moved from the starting position. So the blue is the starting position where the upper incisor was retroclined. So I've actually managed to procline this tooth or get it back into alignment by around 7 millimeters. So for all the orthodontists out there, a lot of people who do ortho, it's a great way to quantify and to monitor your treatment as well. So if you feel that a particular tooth movement which you aimed for is not actually happening, use this tool to see if you're actually getting results with this. Quite amazing. Talking about consultations. Now, why I always emphasize on the fact that doing a proper consultation, we all know that is one of the most important aspects. We know the human psychology, you know how it works. We have the right side and the left side brain. Now, when the patient comes to us, we need to excite the patient's right side brain so that we entice emotions. We, entice a lot of excitement. We show them something. Because the moment we talk about treatment quotations, automatically the left side of the brain becomes active. It starts seeing the numbers. It starts analyzing your bank balance, logic, decision, all those things. So why do we do a digital consultation? A digital consultation is something that will help us entice the patient's right side brain before we talk to them about the treatment plan, treatment options, and the treatment quotation, the most important thing. So that is why it's extremely important to do visual consultations. Let's see, let's imagine a situation where you have a patient who has come to your clinic for, say, a regular cleaning or a scaling. And you see there are wide open spaces that this patient has in the upper arch. What I can do is I can take the patient scan quickly. I can choose something known as treatment simulation. What happens with treatment simulation is the software gives the patient a simulation of what the teeth can get into. So from open diastemas, I can take the patient back into a good aesthetic pleasing smile with the help of, say, aligners, for example. So this is a quick fix solution where you can actually show the patient a before or the current situation along with a specified outcome that you can give this patient. So say the patient comes with yellow teeth, you want to bleach this case, and you can show them what kind of results you can offer to them with this treatment. Extremely, extremely powerful. And that is where I always believe that intraoral scanners are not only a tool to make crown and bridge or implant impressions. It is a great way to sell your practice, to grow your practice, take it to the next level. There's absolutely no doubt about it. Imagine a smile designing case in this instance. You have the patient come in for a smile design, and talking about 3 to 3 veneers. 3 to 3 veneers is probably an expensive affair. So as I said earlier, you want to entice the patient's right side brain. Let's see how we can do it. So you can just upload some patient photographs, select the reference points, and you have this smile library with multiple options as you see on the left side, different shapes to match the patient's personality if you like, or to match the patient's intraoral situation. You can create this kind of template. You can make measurements. You can maintain your proportions. So this is a visual treat to the patient to show them what you can deliver. You can also make some changes to the gingival profiles in case you need to show them. And you can slide your way through the before and after and show to the patient. This simulation can also be sent to the lab where they can actually merge this into your scans and try to replicate this outline that you have created. Pretty interesting. This is another way of doing absolutely fabulous digital consultations. This is a digital mock-up that you can see here. So we've taken a scan with raised bite. This technician has sent us a digital mock-up, which I can inspect. I can show to the patient. I can call for a print of these models, make putty indices, and also provisionalize the patient with this increased vertical dimension. So this is also a great way to convince your patients to go for full mouth cases. And remember the monitoring app which I showed to you all, you can also actually use that to monitor the amount of tooth wear that is happening, for example. So in a jiffy, we've had a bit of an overview about what all options we have. We have a lot of other options like guided surgery. You can now have softwares, synced along with your intraoral scanning systems. You can merge your CBCTs with surface scans, and you can actually simulate implant placement, design surgical guides. You can also design your own aligners. For example, there is an aligner software also which is available these days. You can do your own aligners. But what is the major benefit behind going digital and integrating digital dentistry in your practice? The best benefit that I can make of, and I'm sure a lot of you will agree to this, is it's a great way to grow your practice and take it to the next level. How can you do this? Number one, we eliminate manual steps. We move on to automation. While eliminating manual steps, we are not only maintaining the accuracy and precision, which is always, a bit of a question mark when it comes to manual work, but we are also automating the entire process. We are controlling it better. We are increasing our turnaround time as well. It obviously gives us a major competitive edge over the peers. A lot of patients have gone to dentists with intraoral scanners, always suggesting that that technology is much better than going ahead with taking physical impressions. Faster turnaround, as I mentioned, it's much faster. And this, again, my dear friends, is a very, very important aspect that I want everybody to pay attention to. Increased conversions and increased revenue. Ultimately, we are running a practice to increase revenue, right? So I always regard a scanner as not only a tool to make impressions, but also as a great way to convert more patients, to convince more patients, to motivate them to go for treatment. Patient excitement, you want to keep them motivated with the smile designing app, with treatment simulator, with patient monitoring. And another thing that I cannot emphasize enough on is self-evaluation. It happened with me. Digital technology is quite unforgiving to a dentist most of the time, because you can, see how good or bad your work is on the computer screen, zooming in say 50 times, 60 times, and actually learning a lot. So initially when I used to do the preps, I used to see a lot of undercuts in my preparations. When I started using this software, we could obviously see where the undercuts are. Next time you're probably a little bit more conscious about how you can reduce that screening time and reduce those undercuts, have optimum amount of clearance. It's a great way of self-evaluation and self-learning as well. Excellent communication. This is by far the best way of communicating, not only with your technician, but also with your patients. There is also an option where these days with a lot of scanners, you can also send the scan files to the patients themselves so that they can have a look also. And because you're saving time, you're treating more patients. There's absolutely no doubt about that. And in today's world, we know how important disinfection sterilization is. Imagine having to autoclave those trays. How do you sterilize the impression? How do you prevent contamination when the impression is being shipped from your clinic to the lab? The scanners come with, autoclavable tips. Very, very easy to sterilize and maintain a optimum level of disinfection and sterilization. Now, a lot of dentists will be having this question: how do we witness or how do we use this scanner? Now, Illusion Dental Lab, which are having an E-Famdent booth in the partner pavilion, I urge all of you all to visit them, inquire about the education and experience scanning service, where there is a paper scan model where Illusion Dental, and we send a trained dentist along with a scanner to your clinics, and we can do cases together. Those cases can be sent to Illusion Lab, and you can get a taste of digital dentistry in terms of an intraoral scanner. Everything from crown, bridge, implant restorations, aligners, everything can be done with this. So please, I urge all of you all to visit the e-booth and inquire about the scanning service.
Mahesh, about 2 minutes more. Huh?
Sure, I'm almost through. So, I've always heard this bit of a cliche where we talk about man versus machine, but I've always regarded this as man and machine, because don't forget that the man is actually behind operating the machine. So there's no competition. Man versus machine is not something that I believe in. It's man and machine. Both of us together can make dentistry better. So this is a small thought which I came across during these lockdown days. I came across this interesting term called acrasia. This is the condition in which, while knowing what would be best to do, one does something else through weakness of will. So I noticed that there are a lot of things that I knew were not right to do, but I would do them because of weakness of will. So I suggest all of us take an oath to get rid of this acrasia, start doing the things that we feel are right in dentistry, in daily life, so to speak. Thank you so much for your patient listening. Kindly follow me on YouTube, the Chairside Education channel, to subscribe to a lot of educational videos. and thank the entire team of Famdent. I think I'm finishing in just about the right time, and
Perfect.
I hope we can have some time for questions.
That was a really fantastic presentation, Dr. Mahesh Jagwani, on digital dentistry. And in fact, I have shared very close relations with Dr. Shankar Iyer, who's a renowned prosthodontist from GDC Mumbai, and now he's been in US for the last 26 years or so.
Yeah.
And once when we were just chatting up, and I asked him, like, Dr. Shankar, what do you recommend as the best way of impressioning? Then he said, Santosh, as of today, there's only one way of impressioning, and that is digital.
Absolutely.
That is digital. So I asked him that these machines are a bit expensive, 10 to 15 lakhs. So everybody may not be able to afford it. So what would you suggest next? They said next would be, say, addition silicones. Then I said, there are a lot of people who do not use addition silicones. So what would be next for them? He said, no, there is no next after that. There is impressioning, which is digital impressioning. If it is not possible at all, then it is only and only with addition silicone. There is nothing called alginate in my repertoire. That's what he had said. And I think you may agree with what Shankar said.
Absolutely.
Yeah. So thank you, Dr. Mahesh, for this wonderful inputs. And I'm sure there will be a lot of people who will follow you on YouTube. Please note the name of the channel. I had told about this in the intro also. That is called Chairside Education. And you can learn a lot from Mahesh. And thank you, Mahesh, for joining us, sparing your time, and giving us your expertise. Thank you.
Much appreciated. Thank you.